here we go. Welcome to Art 116. I wanted to let you guys all know that people are signing up for classes for next quarter, and then we're going to try to open up more courses to face-to-face experiences, if not full-time face-to-face courses. I'm going to be teaching 2 classes next quarter: bronze casting, Art 244, which is a night class. It meets on Monday and Wednesday nights, and we do a small sculpture in wax and then cast it in the bronze casting process, the lost wax bronze casting process. Look, here's one now. Here's a little Eiffel Tower that somebody made a long time ago. And so this is made out of metal, it's made out of bronze, but originally these were pieces of wax that were carefully and painstakingly put together to make this kind of modernistic Eiffel Tower shape. And so I'm a figurative sculptor, and so I do figurative stuff like that figure in the background, but you don't have to be a figurative sculptor to take bronze casting. So that's one thing. And then Art 117 is the last in the basic design series. Basic design in spring quarter is introduction to 3-dimensional design. And so we make models, we make small sculptural ideas using design ideas and applying them to sculptural materials. For those who are interested in architecture, one of the projects we do is an architectural model. So it's using 3-dimensional and sculptural materials in a design way to kind of learn about the built environment, product design, because one of the big things that designers do is product design, working with teams to create the outside shape and user interface of something like this. You know, this did not just come into being all by itself. Designers actually had to figure out how to make this and really finesse the user interface for people so that this became a cool thing that everybody must have, and takes over your life and addicts you to a life of looking at small images on your handheld screen. So I digress. Art 117, Introduction to 3D Design, is next quarter. My classes are filling up fast. I don't even know if there's any room in my classes anymore, but I wanted to let you know that I am teaching 2 classes next quarter, and that people are signing up for classes right now. Adriel, I got your message. I will reopen the last assignment for folks so that they can get it in. Sorry that it closed again before you got a chance to upload your thing. So I will get that opened up for you. I was doing a few things before class this morning, including dipping patterns for the bronze casting process. So after class, I will be able to reopen that assignment for you. Okay, today, what are we going to do today? Well, I just wanted to kind of use a little bit of the information that we started to use about plastic color to broaden it out just a little bit more, so that we're not just talking about the space in a still life, but that we can talk about the space generally in illustrations, illusionistic space. And right now that means going to chapter 8. So chapter 8 is the unknown chapter after chapter 7. And I don't spend a lot of time there, but I do like to introduce 2 basic ideas from chapter 8 for you guys to look at. So let me do that by way of death by PowerPoint this morning. We're going to look at a PowerPoint presentation that I've got up on my screen and see what we can do here with you guys. I need to do this, and where am I? I want to do here and get this thing going. Okay, so I hope that you guys can see my slide. And we're going to do just a quick little slideshow this morning, talking about depth, talking about deep depth, vast spaces, all that kind of stuff. Illusionistic space. Now that we've got a little bit of a sense of plastic color, let's see how we can apply that to creating the illusion of depth and space in a composition. So space, the final frontier. I grew up on Star Trek, so that's a big deal. But in art and design, we have two basic kinds of space that we can work with to create illusionistic space in a two-dimensional illustration or painting or something like that. Even in computer art, we use these ideas to create some kind of a depth of space to make the space more interesting to look at. So the first one would be atmospheric perspective. And there's a little bit of explanation that goes along with atmospheric perspective. Atmospheric perspective is used primarily with landscapes. It's used to depict the natural world. And it relies a heck of a lot on plastic color, which we just covered. So let's go to the first bullet point here. It creates the illusion of depth using diminishing size. That means as objects are understood to be moving away from the viewer and back into the background, they get smaller. And sometimes these things, as they move away from you and get smaller, they are overlapped by other shapes that are understood to be closer to you because they're larger shapes. And so diminishing size, overlapping shapes, we get some illusion of depth that way. But basically, the rules of plastic color dominate the idea of atmospheric perspective. So objects that are in the foreground, that are understood to be close to the viewer, they have bright colors, they have sharply defined contrasting details, and those things, the bright colors and the well-defined contrasty details, make them advance towards the viewer. They pop. And they come into the foreground and open up the foreground space in the composition. Objects in the background are small, and they get smaller and smaller the further away they get from you. They have neutralized colors and fuzzy details, making them recede into the background, and therefore moving away from the viewer and moving the space in the background into a deeper feeling of depth in the composition. So atmospheric perspective is all about using color and details to have either bright colors, sharply defined details in the foreground, or neutralized colors and fuzzy details in the background. Basically, fuzzy is a technical term right there that we want to use. There's another kind of perspective that's linear perspective. And some of you guys get introduced to this in high school art classes, and some of you are vaguely familiar with it because you've seen some demonstration on TV or something. But linear perspective is more about drawing, and it's usually used with buildings and the built environment, building interiors, building exteriors, cityscapes, roads, anything that has a kind of a geometric regularity to it falls under linear perspective. And so linear perspective creates the illusion of depth using diminishing size and overlapping of shapes. Hey, wait a minute, this is a lot like atmospheric perspective. But we use linear perspective rules here too. So linear perspective has the edges of objects that are understood to be parallel, like the roof and the ground line of a building, for instance. Those edges, those things that we understand to be parallel edges, actually appear to converge as they recede away from the viewer. These lines extend back to the horizon line where they converge at a point on the horizon line. And we're going to talk about that. I'm going to show you how how linear perspective works with things that are built out of lines and shapes and geometric forms. The viewer's eye level in a composition that has linear perspective, your eye level is level with the horizon line. In fact, that's generally understood in both atmospheric perspective and linear perspective, is that if there's a horizon in the background where the sky meets the ground, your eyes are generally level with the horizon. And so everything that you look up at above the horizon line, you're actually looking up at it from down below. And so you usually see the bottoms of things. When you look at something that is below the horizon line, you're usually looking down at it from up above. And so you can see the tops of things, the tops of boxes, the tops of objects, because they are below the horizon line. And we will look at all of this stuff in just a minute. That was a big first slide. Okay, so we're going to look at something that I'm not going to spend a whole lot of time on, but an idea of intuitive perspective. This is a piece from around 1339, The Allegory of Good and Bad Government by Lorenzetti. And basically, this shows a cityscape, a whole bunch of buildings. But these buildings, even though each building itself has some kind of understanding of linear perspective happening within the building, when you look at all of the buildings together, they don't share a common kind of linear perspective where they all would be receding back to the same or similar points on a horizon line. This was constructed with an intuitive idea of linear perspective, but not a fully realized linear perspective, because that happens in the Italian Renaissance. And so that's going to happen 200 years after this painting was painted. So we have some idea of linear perspective, but not a complete idea of linear perspective here. We'll come back to this. Atmospheric perspective builds on what we were doing with our painting last week. The idea that bright colors, but also highly detailed things where the details are sharply defined, and that there's contrast between colors happen in the foreground. So I'm bouncing my cursor around over here in this foreground area of foliage and tree so that we see shadows that are deeply, sharply defined. We see the edges of objects, whether they're leaves or anything else, sharply defined, and they by contrasty things. So there's light on the surface of the leaves, there's deep shadows underneath the leaves, and so everything looks really contrasty in the foreground. It's bright, the colors are more full spectrum intensity colors. Colors that are at greater chroma have more full spectrum intensity in the foreground. As we move into the middle ground and the background, we see that things start to fade a little bit, that details are not as sharply defined, that colors don't have their full spectrum intensity. They're not at full chroma. Things start to become a little bit more neutralized as we move into the background. When we go to the extreme background, the horizon or the clouds that are up in the sky, we see things that are very grayed out, very, very little color definition in the extreme background. Mostly everything is fuzzy. Nothing is well defined by sharply defined edges in the background. Clouds have fuzzy, ill-defined, amorphous edges on the clouds. But even the landforms in the background are very neutralized. There's no high contrast in the background. And so the background tends to really recede away from our eyes because it participates in this idea of atmospheric perspective. This is what the atmosphere does to colors as they move away from us. They tend to fade, colors get fade, and details get fuzzy because we're looking at them through an ocean of atmosphere. While when we come up to the foreground, we're not looking through that much atmosphere so that we can see colors much more sharply, details much more well-defined in the foreground. So that's the idea in a nutshell of atmospheric perspective. Landscape painters use all the tricks of atmospheric perspective to create dramatic landscape paintings. And so, we look at the, Hudson Valley school of landscape painters from the middle of the 19th century. And they were not only painting in the Hudson Valley, they kind of actually learned their trade at various art schools in the Hudson Valley, but they fanned out across the United States. And during the great westward migration of European settlers in the West, they brought their paints and palettes with them and painted these vast, incredible landscapes of the American West to kind of show just how beautiful and wonderful everything was. So among the Sierra Nevada mountains, painted around 1868 by Albert Bierstadt, one of the Hudson River School landscape painters. And so again, we want to look at objects in the foreground, even if everything is kind of in silhouette because our light source is way in the background back here, thrusting everything into silhouette. Objects in the foreground still have more contrast, and the colors are more full spectrum intensity colors. The greens are actually green in the foreground. As we move into the background, everything gets kind of grayed out and browned out a little bit. And by the time we get up into the sky, we are just really dealing with very fuzzy atmospheric effects on all of the details. And so they're not very well defined, either through details, edges, or contrast between shapes and forms in the background. Everything is much more closely painted in terms of similar contrasts and similar colors and forms in the background. So that's how we open up this vast amount, this illusionistic space of 3 dimensions on a 2-dimensional surface, is by using atmospheric perspective. Other cultures use atmospheric perspective. Utagawa Hiroshige, in his wood block prints, did a same or similar thing. We have the mountain of Mount Fuji, the sacred mountain, is visible in the background. We have all of this details of the ocean and the sea in the foreground. And then in the middle ground, we kind of have some details of the beach and the cliffs and that kind of stuff. The details in the foreground are super highly detailed, sharply defined, and contrasty in the foreground. As we move into the background, things start to have less contrast. They have some some contrast in the background in terms of color and shape and detail. And when we move way into the background, except for this outside contour line on the edge of Mount Fuji, the slopes of Mount Fuji itself are very similar to the colors and treatment of gradations in tone that are in the sky. So we have a little bit of gradation in tone from below the snow line on Mount Fuji into the snow line where it goes white, and that same kind of gradation in tone from gray blue in the sky up into white, happens again in the sky in the background too. These are examples of atmospheric perspective. This tends to thrust the background into the deep background, and the only thing that makes the mountain kind of pop a little bit are the few little black details rendered as contour lines to give some details to the slopes and to the edge contour of the mountain itself. Okay. Something similar in Chinese painting. Chinese painting is often characterized, traditional Chinese painting, by vertical formats, because that helps give us more of a sense of movement into the background. We have our more highly detailed objects in the foreground with higher color contrasts and more sharply defined details. And then as we move back into the background, the colors fade, the details fade. And then when you get all the way to the horizon and the mountains in the background, you have very fuzzy edges and ill-defined colors and details in the background. A lot of this kind of painting is also characterized by your perspective. Your eye is supposed to be even with the horizon, and so you are understood to be up on a mountaintop someplace looking down into the valley. And so you're looking down on top of everything that is below the horizon line, so that you can see the tops of a plateau or table rock over here, and you're looking down on the treetops, you're looking down on the rooftops. But when you're looking at anything that's above the horizon line, then you would be looking up at the undersides of things. You're looking at the undersides of clouds and the undersides of birds or 747 airplanes flying around the world. I'm just joking. Here we go. Let's talk a little bit about linear perspective. Now, this isn't a complete thing. I've only got a couple slides on linear perspective here, but you know, in art history, they always keep coming back to Leonardo da Vinci because he really liked to study linear perspective. And this is one of his famous paintings, even though you may not be a religious person. This is Leonardo's Last Supper. And it was actually painted as a fresco painting on the wall of a dining hall at a monastery. So the monks would be in this dining hall sitting and eating, and they'd be looking over here at Jesus hosting the Last Supper with the 12 apostles. So we want to look over here to the right at this interior space with a schematic drawing that kind of gives us a sense of the one-point linear perspective being employed by Leonardo. Leonardo pretty much makes the Jesus figure in this thing the center of attention. He's placed in the center of the room. His head is also placed on a horizon line, and we can see the horizon in the background through the windows. And so his head is like the point of convergence for everything in this interior space here. So all of the tapestries that are on the walls are all understood to be the same size, and they're all understood to be rectangles, rectangular rugs or something hung on the walls, all at the same height. So their tops all line up on the same edge. But because they are receding in space, they all tend to follow one line that goes all the way down to one point of convergence on the horizon line. And that comes from both side walls. And it also comes from this coffered ceiling. A coffered ceiling is something that was actually developed by the Romans and later picked up on by the Italians in the Renaissance. But a coffered ceiling has beams that crisscross each other and create little negative spaces up within the crisscrossing, which tends to lighten the ceiling, and it makes for larger halls that can be constructed with larger spans going across them. Well, the details of this coffered ceiling, all of these little coffers are little square holes that happen between the beams in the ceiling. They're understood to be square, but as they recede in the distance, they get smaller. And basically, they all operate under this same idea of linear perspective, that each one of the beams, that is a longitudinal beam that is moving away from us, they all are parallel to each other, but they all actually would come, if they were extended out into infinity to the horizon line, they would all converge at this one point on the horizon line. The lateral beams are all just parallel to each other because the lateral beams, in one point linear perspective, the lateral stuff doesn't matter. So the edges of the table and the lateral beams, they just are all parallel to the horizon line, basically. But this is how linear perspective works. So we were just looking at one single point linear perspective, one point linear perspective, where there's an object and two edges of like a square facing object are parallel to the horizon line, and so they don't converge at all. But the sides that are not parallel to us and parallel to the picture plane, this is understood to be a square side of this cube, and the side is it is converging towards a point on the horizon line. And the bottom edge of this thing is also converging towards the same point on the horizon line, and the back edge of this cube. And we can see this cube from the bottom. We can see the bottom of this cube because it's above our eye level. Our eye level is understood to be at the same level as the horizon line. So anything that's above our eye level, above the horizon line, we can see the bottom of it. And it's a magic floating, flying cube because it's above the horizon line. So I was just being funny there. But basically, these are the rules for linear perspective to get these lines. And these lines are called orthogonals. Orthogonal lines are how we can construct the idea of illusionistic three-dimensional objects using linear perspective. And this is one point linear perspective with one vanishing point in the drawing. 2-point linear perspective is when you see the edge of an object, like a building or a tabletop or something, and instead of having the side of the object broadside to you in the composition, we're seeing the corner, we're seeing the edge on, corner on, and so we see the tops of the table, the tops of the box, and so all of these edges are converging to a point on the horizon line. These two edges are understood to be parallel to each other. They follow orthogonal lines back to a single point of convergence on the horizon line over here. And these three parallel edges all follow orthogonal lines back to a point of convergence on the horizon line over here, giving us the illusion of a three-dimensional object that also seems to be receding in space because it gets smaller as it moves away from the viewer's eye from our perspective. Also, our eye level is level with the horizon line, and so anything that's below the horizon line is below our eye level, and we are looking down on it. And that's why we can see the top of this box, because our eye level is up here, and so we're looking down at the box. And painters and draftsmen use linear perspective to be able to create the illusion of three-dimensional geometric objects for us so that we can see them in relief and understand that they're moving away from us in space. And you can create an entire system of, of unified, consistent three-dimensional objects when you're using linear perspective. So I don't know if you guys remember the first slide that I had that was intuitive perspective, where the objects were three-dimensional. The buildings were all three-dimensional, but they didn't all seem to be like all existing in exactly the same space. They were a little cattywampus in their individual interpretations of linear perspective. This is a unified linear perspective. This is Raphael, one of the 3 or 4 Ninja Warrior Turtles. No, more Mutant Ninja Turtles. Yes. Okay. So I'm sorry. Raphael was a painter from the Italian Renaissance. And so we have to look and see where the horizon line is. Looks like the horizon line would be your eye level. Since you are down 3 or 4 steps down here, you're looking at about where the bottom of this doorway is in the background. This arched doorway would have the floor coming up to meet the bottom of the doorway. And this is our eye level. So it's kind of nice to know where you stand, because to know where you stand is to know where you sit in a painting. And if your eye level is right here, then you're everything above this line, above the horizon line, you're looking up at. So we're looking kind of up at all the chins of all of these philosophers that are all gathered in this crazy painting of all of the Greek philosophers and scientists that were revered by the people in the Italian Renaissance when they were rediscovering all of the Greek and Roman art and philosophy and engineering and everything else. So we've got Aristotle and Plato are the 2 main philosophers in the center of this. And it's called the School of Athens because these are all the philosophers that came from basically Plato and Aristotle, the kind of founders of Greek philosophy. And so between them would be, you know, this spot right here on the horizon line. It kind of everything then converges at this one kind of spot, this sacred place between Aristotle and Plato right here. And so this is another very fancy coffered ceiling. So now we have hexagonal coffers and square coffers kind of alternating in this coffered ceiling, which is also following the contours of a barrel vault in the ceiling. And we've got another view of the coffered ceiling over here. So very, very elaborate architectural and geometric ideas can be rendered using linear perspective. So all of these coffers kind of all still line up on all kinds of lines that converge to one point on the horizon line right here. Whoops, I'm sorry. I touched something that I shouldn't have touched. So let's go back to that. And all of the rest of the architectural elements in this hall, all of these edges of these architectural elements, wherever they may be, if they're receding into the background, they're all understood to be parallel to each other, and they're all converging to a point of convergence on the horizon line here. All of these elements on the floor tiles and everything, are also all following orthogonal lines, and they all converge at this same one point of linear perspective right back here between the two philosophers. And oh, by the way, this is supposed to be a portrait of Michelangelo, because Raphael was younger than Michelangelo. Michelangelo was this brooding, kind of nasty, asocial person among the artists of the time. And so while Raphael respected Michelangelo and what he was able to accomplish, he also wanted to show Michelangelo as kind of a brute, sculptor, artistic, creative person, kind of just having a mood down here in the foreground. I think this over here, one of these is supposed to be Leonardo, and I think this could possibly be a Leonardo because he's drawing in a book, kind of with a sketchbook here, and a lot of people are looking over his shoulder in looking at his sketches. And this right over here is a self-portrait of Raphael. Raphael, the young guys are over here in this corner, and this really handsome young guy way over here in this corner is a self-portrait of Raphael. So Raphael, Michelangelo, and Leonardo are all secondary characters in this painting, basically of the major philosophers of ancient Greece. Anyway, this also is a really nice example of one-point linear perspective. And I think I can quit here and come back to you guys, because in a nutshell, that's what chapter 8 discusses. And I usually do a project with you guys somewhere around this point in the quarter where we try to do something with linear perspective and color shapes and whatnot, but I'm running out of time. So I'm not going to do that project. I'd like you to look at chapter 8 and read through it just enough so that you get a sense, get an idea of what linear perspective is, how it was developed during the Italian Renaissance, so that we have a really good sense of observational 1 and 2 point and even 3 point linear perspective. In the modern age, in the 20th century and the 21st century, we have people using 3 points, 3 vanishing points, to be able to even depict tall buildings or spaceships or things that might have actually 3 points of axis, three vanishing points where geometric edges receding in space would actually go to converge at a single point. So you'll find that interesting. I want you to look at chapter 8, read through it fairly rapidly. There will be a few questions on the final exam, the final quiz, about linear perspective. So I want you to have a good working understanding of linear perspective by reading chapter 8. When we come back on Wednesday, we're going to start our last project. And our last project is about crazy color, which I think will be fun because we've got a week and a half left in the quarter and then finals. So we're going to do one more project in the last week and a half on crazy colors. So I got to show you some examples of crazy artists and the ideas of coming up with a color scheme that is just bizarre and not natural. And that's going to be our last thing for the quarter. So we'll do that on Wednesday. Between now and Wednesday, I'd like you to look at chapter 8. So I'm going to say goodbye for now because I don't have anything else to do. Let me just open it up to you guys. Do you have any questions, comments, or concerns for anybody? Please unmute your mic and let me know what you're thinking. And otherwise, please go back to the text and read chapter 8, looking at linear perspective. And I will be talking at you guys again on Wednesday. I'm not seeing anybody with any questions, so I'm going to go. And so goodbye for now. I will see you guys again on Wednesday. Bye-bye.